Morning, everybody. I hope this lecture finds you well and healthy. Gonna keep going with linear functions. So let's take a look here. So what do I mean by a linear function? Well, it's a function that can be written in this form, y equals mx plus b, but I want to draw your attention to this form as well. F of x essentially, I'm not going to say means, it's like, think of it as another name for y. And it's actually a more informative name, because if you think about it, like if I have y equals 2x minus 1, this tells me that whatever value y is, it depends entirely on x. So if I wanted to plug in, say, x equals 3, then that would give me y equals 2 times 3 minus 1. 2 times 3 is 6, minus 1 is 5. But if I change the notation to f of x, now it's important that you don't think of this as multiplication. This is one symbol all together, right? Think of this almost as like your name, right? My last name is Lewis. I'm not going to take a letter away. That would change my name, right? You have to have all the letters there for you to have your name. So this this notation is simply a name, and you need all of it. And so just like I could say y is 2x minus 1, I could say f of x equals 2x minus 1, meaning there is a function that takes x as its input, multiplies it by 2, subtracts 1, and spits out a y. The name of this function would be f of x. Okay, and so now plugging in 3, instead of writing x equals 3, so I could say f of 3 equals 2 times 3 minus 1. So f of 3 equals 5. Either way, you've got the point 3, 5. In this case, on the left, we're thinking of it as xy. And on this case, on the right, we're thinking of it as x. And then what you get when you plug x into f. Okay? It's notation, that's it. But you want to get used to it, because I know that new notation can feel kind of intimidating at first. Okay? Just while we're at it, what if I wanted to find f of 5? Well, that would mean plug in 5 for x. And you would get 2 times 5 is 10, minus 1 is 9. Okay? So this notation is essentially telling you how you're getting f, or what you're plugging in for x to get f. Okay. All right. Our big goal here is to try to ultimately graph these, and a graph without having to find points, right? In the first section, we had to find all these points, and sometimes it's tedious. Maybe there's some other ways to do it. So the first thing I want to do is talk about intercepts. There are x-intercepts and y-intercepts. And just as the name suggests, right, you have the x-axis and you have the y-axis. An intercept is going to be where that line, or any graph for that matter, crosses that x-axis. Can't talk now, x-axis or y-axis. So here's a question. What is the value of y at an x-intercept? Well, let's take a look here. This would be the x-intercept, right? The graph is crossing the x-axis. Well, what would the y-coordinate be for this point? Notice that we're sitting on the x-axis. So we're not above it, we're not below it, we're right on it. Which means if you think of y as like elevation, it's like sea level. This is 0. Okay? So the value of y is 0 at the x-intercept. Similarly, the value of x at a y-intercept, well, you're starting at x equals 0 and just moving up or down. So the value of x is 0 at the y-intercept. Okay? So let's try to find some intercepts. We know the values of x and y, right, when we're at an intercept. So let's start with, say, the x-intercept. So if I'm at the intercept, the x-intercept, then y is equal to 0. Well, if I know what y is, then this equation that used to be 2 variables is now just 1 variable. See, I'm plugging in 0 for y. So my y term is gone, right? That's just 0. So I get 2x equals 14. Divide by 2, and we get x equals 7. And so my x-intercept is the 0.70. Okay? Don't forget it's a point, right, on the graph, but it's just also on the x-axis. Now, what about y-intercept? Well, with the y-intercept, I know that x is 0. And so if x is 0, I'm going to replace my x in the equation with 0. And so 2 times 0 plus 7y equals 14. 2 times 0 is just 0. So we're left with 7y equals 14. So y equals 2, and my y-intercept then is 0, 2. Okay? How about B? Well, we can play the same game here. Let me put this down a bit. So I can let, well, I'm sorry, let's get a little more organized. Let's start again with our x-intercept. So my x-intercept, that means y is going to be 0. And so negative 5x plus 6 times 0 equals 100. So negative 5x equals 100. Divide both sides by negative 5. And you get x equals negative 20. And so the x-intercept is going to be negative 20, 0. Okay? Remember, this is my answer. This is my intercept, right? An intercept is a point, so you need an x and a y. Just so happens that we know the y is 0. All right, let's do the same one. Let's do this again. But with the y-intercept, which means we know x is 0. And so negative 5 times 0 plus 6y equals 100. So 6y equals 100. I'm going to divide by 6. And I'm going to get y equals, well, let's just reduce this, right? This reduces to 50/3. Or if you want, you could call it 16 2/3. You take your pick. But either way, my y-intercept will be 0. And I'll call it 16 2/3. Why not? Okay. So there is my y-intercept. All right. Now, let's move on to graphing. Okay, so we know that to graph a line, you need how many points? Right, you need 2 points, right? Any 2 points, there's a unique line that goes through those 2 points. And what did we just learn how to find? Right, 2 particular points, the intercepts. So if we use those intercepts as our 2 points, we'll have the 2 points that we need to graph a line. So that's the first technique we want to use for graphing lines, is using intercepts. So let's take a look here. 2x plus y equals 6. First, I'm going to find the x-intercept. So the x-intercept means y equals 0. And so I get 2x plus 0 equals 6. So 2x equals 6, divide by 2, and we get x equals 3. Now remember, this is actually the point 3, 0. So go at this point and plot that point, okay? Don't wait, okay? Next, we're going to find the y-intercept. Where does this graph cross the y-intercept? So now I'm going to let x be 0. And in this case, we'll have 2 times 0 plus y equals 6. So y equals 6. But again, this is the point 0, 6. So here's 0, 1, 2, 3, 4, 5, 6. And once I've got those 2 points, then I can graph with a line. And here's one of the big rules of, or tips of line graphing. If your line misses your point, draw a bigger point. Sorry, that's a horrible line. Let me try that again. It's bugging me. So let's see here. Oops. All right, that's more like it. All right, let's try again. Y equals negative 40x plus 5x. All right, so my x-intercept, I'm going to have y equals 0, which is going to give me 0 equals negative 40 plus 5x. If I add 40 to both sides, I'll be looking at 40 equals 5x. Divide by 5, divide by 5. So I get 8 equals x. And again, that's really the point 8, 0. So 1, 2, 3, 4, 5, 6, 7. And of course, I ran out of room. So we'll call that 8. I just let this keep going. And then my y-intercept. So notice I went by ones, right? 1, 2, 3, 4, this is 5 here, and so on. But my y-intercept, let's see here, x is 0, which gives me y equals negative 40 plus 5 times 0, which is negative 40. So I've got the point 0, negative 40. Well, I don't have 40 spots here, but I can fix that. How about we go down by tens? Okay, so negative 10, negative 20, negative 30, negative 40. I've got my 2 points, and there we go. There's my line. All right. Okay, so that's intercepts, and that's the first way that we are able to graph a line. We're going to go to next is slope. So go ahead and work on some problems like this, review stuff, and then come back and take a look at the slope lecture.